Okay, student, let's see what is there in this question. Two isolated point masses, P of mass m and Q of mass 2m, are separated by a distance of 3d. X is a point, a distance d from P and 2d from Q. What is the gravitational field strength at X and the gravitational potential at X? Okay, so we want to find the gravitational strength and the gravitational potential. So before we move into this question, let us try to first understand what is gravitational field strength and a bit information about that. So what is happening is, like, when we want to study this field, like, there are two methods in which you can do this. Number one is you can consider the forces. So in this case, in the gravitation, we have this formula. Clear? Now if we go for force per unit mass, so this is called the gravitational field intensity or gravitational field strength. So gravitational field strength is the force experienced per unit mass. So we will just assume that the mass is 1 kg, or even if there is no mass here at the point X, even then we can define it, because it will be the mass, it will be force per unit mass, whatever be the mass. So overall, the gravitational field intensity can be written as gm by r square. So this is basically, this mass goes to the denominator, to the other side. It is force per unit mass. So this becomes the gravitational field strength. So we have the formula, and now we can even find what is the net gravitational strength. Let's see. This I, like in many books, it is written as I, because it is gravitational field intensity or gravitational field strength. In IB books, it is usually written as G. G and I, they are two different physical quantities having same magnitude and same direction. Both of them are vectors. So they are technically the same things, but from physical point of view, from physics point of view, we can say they two things, they are completely different. This is defined as force per unit mass, and g is literally the acceleration, and the unit is given by meter per second square. Although even these two units are completely connected with each other, no doubt about it, but still these two are different physical quantities. But IB books, they do not talk about I, they only use G as a symbol, so do not get confused. So this is gm by r square. So let us first find the IP. So IP is gm divided by d square. And what is IQ? It will be g 2m divided by 2d square. So it will become gm by 2d square. Clearly this is IP divided by 2. This is IP divided by 2. So the intensity is now becoming half. But now we want to find the net gravitational field strength. So at X, P is attracting it like this, Q is attracting like this. So both of them are in opposite direction. We will subtract them. So what is the net I? It will be gm by d square minus gm by 2d square. So you would be getting the answer gm by 2d square. So that will be the correct answer. So this is wrong, this is wrong. So A and B are wrong. So answer will be in C and D. The option C and option D is not shown in the visual here. So wait for it, I will show you later. So the answer will be gm by 2d square. That is clear. So this is the first part of the question. Now what is the second thing? Second thing is gravitational potential. Before that, we have to learn a couple of things. So just because of the, like, force, we first find the expression for the potential energy, gravitational potential energy. So this is given by gmm by r, and it is always negative. So this is the point where we start our discussion now. So potential energy is given by negative gmm by r, and when we find this potential energy per unit mass, we define something which is called potential, which is the gravitational potential in the case of gravitation. So that is defined as potential energy per unit mass, the formula for which will be given by negative gm by r, where m is the mass of the central body or the source body, and r is the distance of the point from the center of the body. Okay, so this is the potential. Now we are going to find Vp and we are going to find Vq. Let me clear out some space and see. Okay, so Vp will be given by C. Both of them are gravitation. The potential is always negative, no doubt about it. So we will always take it negative. So it will be negative gm divided by d. As per q is concerned, it will be negative g. The mass is multiplied by 2. D is also multiplied by 2. 2 and 2 gets cancelled out. So we are getting the same answer. Negative gm by d, negative gm by d. Potential is a scalar quantity, so there is no concept of acting opposite or acting in the same direction, getting subtracted or something, nothing like that. Gravitational potential is always negative, so we would be adding them, simple. So our net potential will be negative gm by d minus gm by d, so it will become negative twice of gm by d. Clear? So the potential is negative twice of gm by d. So that is the correct answer. So even this is not right here. uh, I believe I am absolutely correct. Okay, let's see the options. Okay, so yes, D will be the correct answer. As you can clearly see, the net gravitational field strength is given by gm by 2d square, and the net gravitational is twice of gm by d, and still it is negative. So this is how we do it. Let us see what is the answer given in the mark scheme. And yes, the mark scheme also says that the answer is D. This is how we do this. Now, this question is one of the very important question, and please watch this video a couple of times. Why I'm saying that? Because the same question is going to occur when you are going to do your electrostatics. For the new syllabus it is D2, for the earlier syllabus, old syllabus, it is topic 5. You would be getting the similar questions in topic 10 also from the old syllabus point of view. So this question is very important. It is very famous with IB. Do not neglect it. Watch it twice or thrice. Okay, dear students, this is Professor Varun. Thanks for watching. Bye.